Why Supercross Factory Bikes cost $200,000. A production 450 costs around $10,000 at the dealer. The factory version of that same bike, the one Jet Lawrence or Chase Sexton, runs approximately $200,000 when you account for the full program. Not the sticker price of a single machine sitting on a stand, the total cost of everything that goes into building, developing, and running one of these bikes at the highest level of the sport. Base bike, $12,000. This is the only number that looks familiar. The factory team starts with the production 450 as a platform. Same bore, same stroke, same basic architecture. Why keep the production base at all? AMA homologation rules. The rules require that the engine architecture, frame design, and certain displacement parameters trace back to a production model sold to the public. That's what keeps this nominally the same motorcycle you can walk into a dealership and buy. But from the moment it arrives at the race shop, it gets stripped to bare components and rebuilt from the ground up. Stock bodywork stays for branding and homologation optics. The subframe gets evaluated, often replaced with a lighter aftermarket unit. The stock airbox gets pulled and analyzed for flow restrictions. The stock exhaust goes straight in the bin. The production swing arm gets measured, weighed, and frequently substituted for a prototype unit. Think of the $12,000 not as a bike that gets raced, but as the legally required starting point, the skeleton everything else gets built around. Engine program, $50,000. This is where the gap between what you can buy and what they race becomes real. The cases are machined to tighter tolerances than production spec. Tighter clearances mean less energy lost to internal flex and vibration at high RPM. The crankshaft is balanced to reduce rotational mass inefficiency. Connecting rods are titanium or premium steel, shot peened to relieve surface stress and individually weighed so the rotating assembly is matched within fractions of a gram. Pistons are forged with custom ring gaps, which controls blow-by and oil consumption at race temperatures. The cylinder head is hand-ported. A factory engine builder physically removes material from the intake and exhaust ports using a die grinder and carbide bits, matching port shape to the cam profile to maximize airflow velocity and volume. That process alone takes hours per head and cannot be replicated at production volume. Cams are custom ground with lift and duration profiles not available off the shelf. Duration affects how long the valves stay open, directly controlling how the power band loads up off the bottom and pulls to the top. Valve springs are titanium, which reduces reciprocating mass and allows the valve train to follow the cam accurately at RPM levels that would float steel springs. The transmission gets blueprinted too, gear engagement dogs measured and matched so shifts are crisp and positive under full power. The clutch pack is upgraded with friction material rated for sustained race abuse without glazing mid-moto. The entire engine is assembled to tolerances far tighter than the factory spec sheet requires. The result is an engine making 5 to 10 horsepower more than production, spinning faster, and holding that output consistently across a full season. The $50,000 covers components, machining hours, assembly, dyno time, and the ongoing rebuild program, because these engines get freshened every 2 to 3 races, not every 2 to 3 seasons. Works suspension, $50,000. This matches the engine program dollar for dollar, and once you understand what factory suspension actually is, that makes complete sense. Production forks and shocks are valved to work acceptably across a broad range of rider weights, speeds, and terrain types. Factory suspension is engineered for one rider, one speed range, and the specific violence of a stadium supercross track. The Showa A-Kit, KYB factory closed cartridge units, and WPX ACT Pro components used on factory bikes are hand-assembled at the suspension manufacturer's race division. Inner tubes are machined to tighter tolerances with surface finishes. Kashima coating, emerald treatment, DLC, that reduce stiction so the fork reacts to small square edge hits instead of skipping over them. That matters in the whoop specifically. A fork that sticks even slightly in the mid-stroke can't track the face of each whoop individually, and the bike gets pushed offline. The valving stacks inside the damping circuit, those thin shims that meter oil, flow under compression and rebound, are custom configured for the rider's weight, speed, and throttle style. A rider who is aggressive on initial compression needs a different high-speed compression stack than a rider who is smooth and momentum-based. The factory suspension tech adjusts these stacks based on actual data from the data acquisition system. Not feel alone, but logged fork travel, shock velocity, and G-load numbers from the previous session. Spring rates are custom wound in titanium to each rider's weight and the specific stiffness demands of SX versus outdoor. SX tracks hit hard and fast, demanding stiffer springs and faster rebound to keep the chassis from packing down through a rhythm section. The shock gets completely rebuilt after every race weekend. That's not optional maintenance, it's the program. The $50,000 reflects hardware cost, custom setup, and a full season of rebuild labor from a specialist whose only job is this. Electronics, $15,000. A production EFI system runs a fixed fuel and ignition map with a handful of selectable modes baked in at the factory. A factory bike runs a fully custom ECU with proprietary software managing fuel delivery, ignition timing, engine braking coefficient, and traction control, all independently adjustable via laptop between practice sessions. The traction control system on a factory SX bike isn't a blunt cut and restore throttle limiter like consumer systems. It reads front and rear wheel speed differential, and when it detects rear spin, it pulls ignition timing in micro increments, shaving just enough power to recover traction without the rider feeling a hard intervention. The difference between a map that cuts too aggressively and one that's dialed right is the difference between a bike that loses drive out of a flat turn and one that hooks up cleanly. Launch control is another factory-only feature. On the gate, the rider holds full throttle, drops the clutch, and the ECU manages the power delivery through the first few feet of acceleration to prevent the front from lifting and killing drive. The mechanic and data engineer review throttle position, wheel speed, lean angle, and suspension travel data logged at several hundred samples per second after every session. They can see exactly where in a rhythm section the rear stepped out, how deep the suspension was loaded on the face of the triple, and where the rider was still on the brakes when he should have been pinning it. The $15,000 covers ECU hardware and software licensing. It does not cover the engineer required to operate it. That labor is embedded elsewhere in the program cost. Prototype parts, $20,000. These are the components that don't exist in any catalog. Frame geometry adjustments, head angle, swing arm pivot height, triple clamp offset, are dialed to the individual rider's weight distribution and attack position. A taller rider with a more upright attack position loads the front end differently than a compact rider who rides low and aggressive. The chassis has to be built around that. Custom linkage ratios change the rear shock's leverage curve through the stroke. A progressive ratio builds resistance as the shock compresses, which controls bottom out on big hits. A more linear ratio gives a more consistent feel through the mid-stroke, which some riders prefer in the whoops. Custom exhaust headers are developed specifically for the current cam and port spec. Header diameter and length directly affect where the power band peaks, and the factory system is tuned to match the engine program, rather than being a generic performance upgrade. Billet hubs machined to tighter tolerances than production castings, hand-laced wheels trued to sub-millimeter runout, titanium fasteners throughout, custom seat foam density, one-off handlebar bend geometry specific to the rider's reach and bar height preference. Every contact point between rider and machine is a prototype component. These parts are expensive not because the materials are exotic, but because each one exists in quantities of 2 or 3, meaning per unit machining and development cost has nowhere to spread. The $20,000 is what zero-volume manufacturing actually costs. Testing and development, $60,000. This is the largest line item after the engine, and it's the one that never shows up in photos. Every custom cam profile, every valve stack, every ECU map, every linkage ratio was arrived at through hundreds of hours of work that happened before the season started. Pre-season testing programs run for months. The race rider and a dedicated test rider put laps on multiple bike configurations back to back. Same track, same conditions, direct comparison. Engineers analyze data between runs, make targeted changes, go again. Suspension techs run isolation tests. Change one spring rate, log 10 laps, compare. Engine builders run dyno sessions on multiple head configurations and exhaust pairings to find the peak combination for this season's power delivery target. The rider gives subjective feedback. It's pushing in flat turns, the power is abrupt off the bottom, the front is washing in ruts, and the engineering staff maps that feedback onto the data to find the mechanical cause. Track rental for private test days runs thousands of dollars per day. Staff time, rider, mechanic, suspension tech, data engineer, engine builder, multiplied across weeks of preseason testing adds up fast. The $60,000 is the cost of arriving at Anaheim in January with 0 open questions on the bike. Every setting is known, every map is validated, every prototype part has been tested under race conditions and confirmed. When the gate drops, the only variable left is the rider, and even that's been prepared for. $200,000 is the gap between 1st and 7th place. Every dollar is spent to close it. Next video, we're going the other direction. Every dirt bike brand on the market, broken down for what it actually is, and more importantly, what riding one says about you. KTM, Honda, Yamaha, Kawasaki, Husqvarna, GasGas, Beta, Sherco, the machines, the culture, the reputation, the rider type each one attracts. Whether that's fair or not, it's already built. Hit subscribe so you don't miss it.